It's time for us to start speed dating so that we can get started with our event. For those of you who do not know, my name is Ann Merchant and I work for the National Academy of Sciences. And my role is to say a little bit about what the National Academy of Sciences is and does, but I'm not going to say a lot about that. We are a private nonprofit institution in Washington, D.C., created more than 150 years ago to provide good evidence-based input to primarily the federal government so that they can make good, sound policy. So the other thing I would say about the Academy is that we cover a range of topics, whether we're talking about the social sciences, the biological sciences, the physical sciences, health sciences, engineering. And so that's oftentimes the inspiration for our speed dating events, because there is so much in science, so much that is cool and interesting, that sometimes you want that smorgasbord. And so that's what our event is today. It's to bring together a group of people who study a variety of things and give really short talks about that. And so usually we do this in a real room under the auspices of the Science and Entertainment Exchange, and Rick is the director of that program. And he's going to take us not only to give you a little explanation of what the exchange is, but to give you a sense of what you're going to see, because we've worked really hard to figure out how to bring this from the real world to a virtual world in a way that made sense, because we can't translate it exactly, but we think we've come up with something that maybe gives you a sense of what speed dating is like. Usually there's keys involved and it's very ice storm, and we're not going quite in that direction this time, but there is no actual dating. So anybody who thought they were coming here for actual dates with scientists, it's not exactly what it is. But it is something cool and it is fun. And Rick, I'm going to hand it over to you to talk about that.
Hi, everybody. My name is Rick Lovert. I'm the program director of the Science and Entertainment Exchange. First and foremost, I need to say happy birthday to my mother. It's my mother's birthday today. And look, in these weird times, please don't forget to call your mother. So, secondly, thanks to the AV team at Spark Street for making this whole thing happen today, and the team at NAS, Courtney, Jeff, and Sachi. Also, one last credit, thank you, Michael Wong, for live tweeting today. Please, he's the host of the podcast Strange New Worlds, so please check that out if you get a chance. So, what is the Science and Entertainment Exchange? We are a program of the National Academy of Sciences. If you are a writer, producer, studio executive, actor, and you have a question about science, you can call our program and we will connect you with a field expert for free who will help you in the development of your film. We've done over 3,000 consults since we opened our doors over 10 years ago. Films like Avengers Infinity War, Man of Steel, Black Panther, Captain Marvel. And we're always doing these events in Hollywood. We have for many years, but now we're taking this online. So if you are a STEM professional who's never heard of us and just wandered into this event online and you're like, wow, that sounds kind of cool, we're always looking for scientists and engineers to volunteer. So please reach out to us. I also want to thank our sponsors, in particular, Howard Hughes Medical Institute, who made this event possible, and all the individual donors who gave. That money that you gave to this event goes directly back into more of these. So thank you for making that possible. So science speed dating normally has a totally different structure than what you're about to see. This is a big experiment today. We're trying a bunch of stuff. So please forgive us if it all goes crazy. We don't think it will. We think it's going to be amazing. So basically what you're about to see are 5 scientists. But when each scientist goes on, there are going to be some people in that area with the scientists. So first, the scientist is going to have 7 minutes to say something incredible. And then the people around the scientists, who are sort of some of our all-star question askers from over the years, just interesting people who we think ask cool questions, are going to respond and ask questions. Now, within that group, there is also someone who we have labeled for now an MC, who will also be scanning down here at the bottom of your screen. There should be a little bubble that says Q&A. So if you are an audience member and you have a question for the scientists, the MC will take a look at that, and hopefully we have such limited time. There's only going to be 7 minutes to respond and 7 minutes for the scientists to speak. So we are so sorry if we don't get to your question. as I said, we're trying a bunch of stuff, and you know, hopefully this will be fun all the way around. But anyway, so I think that's it. Is that it? Is that all I had to say?
Basically it. I think we also want to thank our speed dating scientists. You know, everyone is at home, they're not on airplanes, but I can tell you from experience that they are all still extremely busy. We have with us a member of the National Academy of Sciences from our NAS Council, and I know she's busy, and all of these people are at home, but doing their work. So the fact that they made themselves available for this, we want to thank them as well. And I think that what Rick and I most like about the programs that we work on is that we learn something new every time we have an event. So we, like the rest of you, when we turn this over, we'll be sitting here and listening. And as Rick always likes to say about speed dating, let it go and they'll blow your mind. So that's the point.
Oh, there is one last thing. So I am going to be timing our speakers. That's actually a picture of my son, not a timer. But the iPhone will be I'll be saying stuff. You'll be hearing my voice basically when on the timer we hit certain beats. So please don't be weirded out when all of a sudden you hear me say, "You have 1 minute," because that's just part of the game.
That's his job.
It's my job.
His job. All right. So our job now, I guess, is we're going to go away. And then we're going to turn it over to our speed dating scientists and their guests.
See you in a minute.
No, you just see what I was saying.
Okay, I'm Diana Reese, and it's absolutely a thrill for me to talk to you today. I want to start by saying, first of all, I study dolphins. I've been studying them for many years. I wish you could all go out to a dolphin pool and meet a dolphin face-to-face or face-to-flipper. But let me tell you a little bit about what I've discovered. Dolphins are the second most encephalized species on this planet. Us humans, have the largest brain relative to our body size. Our brains are about 7 times larger than you would expect, given our body size. But the bottlenose dolphin has the second largest brain relative to its body size. It's about 4.5 times larger than expected. Now, it's not just size that counts, though. Like us, dolphins have a very complex neocortex. And although it's organized in ways different than our own, it's involved in problem solving and decision making and many of the higher cognitive processes that we equate with our human intelligence, such as self-awareness, empathy, and other communicative processes as well. And like us, dolphins are socially complex. They live in fusion-fission type societies in the seas, forming and maintaining long-lasting alliances, friendships, like we do, making new ones, keeping the old ones, working together in cooperation and coordination of their behaviors. And they use many kinds of communicative signals, whistles. They have a varied whistle repertoire. They use sophisticated echolocation and a variety of other behaviors in communicating with each other without cell phones. They have to maintain contact in their ocean environment. So notably, dolphins are amongst a handful of species that are also vocal learners. They learn the signals they use, and they show a strong proclivity or tendency for both vocal and behavioral imitation. Dolphins and whales, they're called cetaceans, and primates, that we're primates obviously, and so are the great apes and monkey species, diverged from their last common ancestor about 95 million years ago. Yet despite our evolutionary distance and profound differences in our body forms and our brain organization, we share many social and cognitive traits. So the dolphin actually affords us the chance to study intelligence in another large-brained and highly social non-primate that's about as alien from us as you can get. In fact, I often refer to them as non-terrestrials, not extraterrestrials, but non-terrestrials, as they've evolved in and live in a totally aquatic environment. Now, my research over the past 35 years involves trying to understand the nature of dolphin intelligence and their communication. Most importantly, though, I've tried to use approaches that allow me to partner with them and to get glimpses of their form of intelligence. I want to briefly share today in this little bit of time just a few of the approaches and experiments we've used using a range of devices, simple devices like mirrors, as well as underwater keyboards and a touchscreen. My colleagues and I have used a mirror, a wonderfully simple device, to investigate dolphin intelligence and their level of self-awareness. The mirror is an effective tool because it elicits observable behavior that reflects, all puns intended, the internal and unobservable mental states of individuals. Let me explain. Mirror self-recognition is an index of self-awareness, which has long been considered unique to us humans and a hallmark of our human intelligence. Until in 1970, when Gordon Gallup demonstrated this in our closest relatives, the great apes. When apes were exposed to a mirror, they showed 3 basic stages of behavior leading to mirror self-recognition. And these different behavioral stages reflected changes in their mental state. They first exhibited social behavior as if they were viewing another ape in the mirror. Then they exhibited these highly repetitive and odd, unusual behaviors as if they were testing the contingencies or comparing their behavior to the guy in the mirror. And then they appeared as if they were understanding that they saw that image as their own, because they started showing the second kind of behavior, which was self-directed behavior, a third kind rather, which was self-directed behavior, using the mirror as a tool to view themselves, to view parts of their body they couldn't see without the mirror, to do unusual movements in front of the mirror. It was quite fascinating, much like what we do in front of the mirror. The use of a mark test further confirmed this ability, testing if apes would touch a mark that was placed on a location on their body that could only be seen in a mirror. Well, for the next 40 years, despite tests with other species, apes remained the only non-human species to show this ability. The dolphin, however, was an excellent candidate for the mirror test, and in 2001, we exposed 2 captive-born male dolphins at my lab at the New York Aquarium. Their names were Presley and Tab, and we gave them an underwater mirror. Both dolphins showed strikingly similar phases and strikingly similar behaviors to what we saw the apes show, very similar kinds of self-directed behaviors, and both dolphins passed multiple mark tests. You can imagine we had to modify the mark test given the no hands problem. Obviously dolphins just have flippers, not hands, so they couldn't touch themselves. But the criteria for passing the test in the dolphin was that after being marked, they would swim directly to the mirror, and upon arrival, they would position their body in such a way to expose that mark. Notably, this was the first non-primate to show mirror self-recognition, and this provided a strong case for cognitive convergence in these evolutionarily diverse species. By the way, 5 years later, my colleagues and I tested Asian elephants and found they also showed this capacity. Well, many, many years ago, in another aquarium in California, we gave 2 dolphins an underwater keyboard to see how they would use a system that gave them choice and control over obtaining preferred toys and objects. And so I want you to imagine you're a dolphin. You approach a keyboard displaying visual forms. If you touch one of the forms that's a triangle, for example, you would hear a whistle, a novel computer-generated whistle, and get a ball. If you hit another symbol, you would hear another type of whistle and get a rub or a tickle from us. So they learned if they used this keyboard, they could hear a sound and get a particular object or activity. Very quickly, the dolphins started to use these signals in appropriate ways. They started to use them before they hit the key. They would whistle ball before hitting a ball key. They would use ball when they were playing with balls. They even came up to us and whistled rub and then rolled over for a rub. Without explicit instruction from us or training, they showed the emergence of self-organized learning. Today, my colleagues and I are using a new form of a keyboard. It's a much more advanced interactive touchscreen that anything you can put on a computer, you can put on this underwater touchscreen. We've piloted this D-pad, and we're in the first stages of learning how these dolphins will use it. I hope I have more time in our Q&A to talk about this, but it's my hope that in giving dolphins this opportunity to partner with us, to interact with us, to use this kind of interactivity, that we can get a wider and deeper window into the mind of the dolphin. And finally, I've had this wonderful opportunity to work with these magnificent minds, and I hope that our collective science will create much more respect for these animals and global protection for them. Thanks.
Okay, Diana, your time is up. Ahmed, it's your court for 7 minutes.
My name is Ahmed Best. I'm an active director and host of the Afrofuturist podcast, and I'm honored to be the MC for Diana Reese. I will be fielding questions from people online and from our illustrious group of people watching Diana Reese. And I just want to kick this off because we only have 7 minutes, and there's a lot of stuff about dolphins. They got huge brains. So
okay.
I want to start with this first question. And this kind of goes with how we're all living now. Are there instances of dolphins living in isolation or self-isolating? And what does that do to the pod or the community of dolphins?
Yeah, that's a great question. So in fact, I investigated one of these situations with a well-known dolphin named Jojo down at Turks and Caicos many years ago. People reported he was alone and he would solicit behavior from humans. When we got down there, we don't know why he's isolated, but what we saw was that he really was alone, played with people, but then when we got into the water with him and watched him, we actually saw him going out and being with other dolphins as well. It's a mystery why some of these animals stay alone. Again, we don't know if it's due to some sensory problem they have. It's one of those mysteries that we need to know more about. That's a great question.
And along with that, do dolphins know when they are in captivity because of their enormous amounts of intelligence? Are they aware that they're in an enclosed space being studied?
That is another great question. These are questions we can't ask dolphins directly. And from their behavior, let me say that most dolphins that are in captivity, at least in the United States, were born there now. So this is all they've known, which is pretty strange when you think about it. So we really don't know do they know there's anything beyond that out there. By the way, I'll just mention that we're currently, oh, sorry, go ahead.
No, please.
No, I was going to say, using this new keyboard, we're actually showing dolphins pictures and videos of wild dolphins, and giving them choices between watching wild dolphins in this open environment and dolphins in the pools adjacent to them. And they're equally seem to be interested, although we haven't finished the analysis, of watching both of them and following movement on a video screen. I mean, these are dolphins that have never seen video, and they seem to understand that this somehow represents some reality. They're even using video games like Whack-A-Fish and hitting every fish first time out.
Here's another question from the internet. How far do you think sentience extends? What other animals might be sentient? Do you consider dolphins sentient creatures?
Oh, absolutely. I think from what I've seen and from what my colleagues have seen, if we're talking about sentience as conscious agents, yes, they are. And I think the more we see, more studies we have with other species in this world, we're finding surprising flexibility and intricacy in their behaviors. We used to think we were the only thinking creatures on this planet. The question's not now, do other animals think? It's how do they think? And we share the branches of this tree of evolution with all these other thinking creatures.
So Diana, I got a question for somebody in the room. David, go ahead.
Yeah, on that point. Hi, Diana. There's been, I think in the last decade or so, there's been some high-profile folks making moral arguments based on sea life, particularly lobsters. But Alistair McIntyre is a virtue ethicist who specifically referenced dolphins for a system of virtue ethics, independent rational animals. And as a species that's in a different environment, but that is sentient, and that does have some of these complex social systems, have you seen ethical behavior or moral behaviors being normed, enforced, or just arising in dolphin societies?
Yeah, it's a great question. Thanks for asking it. So we've certainly seen things like empathy, which is sort of putting yourself in the place of another and acting appropriately. Dolphins, from historical accounts, have been known to save sailors lost at sea. These are animals that aren't even related to them. They're different body forms. And I can tell you, I have a collection of newspaper articles about people that said they were saved by dolphins. In the tsunamis, that dolphins brought a group of people back to shore right before the tsunami hit. But I've personally watched dolphins going without food for days, holding up an ill or injured poolmate. And I do think they have a sense of others and self, and also some morality there. So I'm hoping that we will increase our consideration and give them global protection. I think they've been helping us for centuries.
Another question in the room, Moon. Go ahead.
Do you ever, how much access do you have on a regular basis? And can you say something about pink dolphins? Are you studying those as well?
No, I wish. Thanks, Moon. That's a great question too. I haven't been studying the pink river dolphins. I wish I could. I've been working for a long time with dolphins in aquariums to try to enrich their world by giving them interactive systems and be able to learn in controllable ways what their minds are like. But we're also working in the wild now. We have field studies in Belize and Bimini, and you see it's that marriage between those two types of observations you make that make me go, wow, these are magnificent minds. These are amazing species that have evolved in many ways parallel to us. It's not, are they more intense?
Have you shown them?
Have they? No, no, not yet. No, they actually probably couldn't see the color pink. They probably would see it as gray because dolphins don't have the same kind of color vision. They see blues, greens, maybe violet. Yeah, but not quite pink or red. Yeah. But they'd see the dolphins, and it would be really interesting. Yeah, sorry.
1 minute.
No, go on. 1 minute. Keep talking.
No, I want to hear more questions.
Okay, here's another question.
I
have a couple of different questions online from people talking about ethics and dolphins, and they're asking me questions about what we would consider like criminal things that dolphins might do. Is there like some kind of a dolphin behavior that we would consider as human beings to be outside of the norm of society?
Oh, that's a really interesting one. Yeah. So for dolphin societies, for us to say for a dolphin society, what's outside of the norm, I can't say because I'm not a dolphin. What may look odd to us or criminal to us may be quite normal within a dolphin realm. And I think we have to be careful, when we think about that. We may not understand how that functions.
Right. Diana, you have a question.
Well, I think this goes along the same lines of like, are we looking at the mirror self-recognition and also choice and control as a way to also functionally start to understand the brain? Because even human brains, we understand like what, 15% of it. So I'm wondering, is that all leading to understanding just like how the whole neural system in the dolphin works?
No, we're basically able to ask these questions about intelligence. We're just starting. We actually know very little, but these are a means, giving them choice and control. I mean, think about it. If we met an alien or an alien came to us, we're not going to train each other. We want to engage. We want to try to find a way to communicate. So this keyboard sort of functioned as a communication board as well, giving them symbols, giving them a voice so that they could start interacting with us. And they did by imitating these sounds. We want to go much, much further. This was a baby step. The mirror literally is a way of getting reflections of their mind. It's kind of getting out of the way and letting them show us their best stuff. I talk about partnering.
That's time. Thank you guys so much. We'll have our next speaker
Thanks,
up.
everybody.
Thank you so much. Thanks, Rick. Thank you, Diane.
Thanks, everybody. Okay. Thank you.
All right, thanks everybody for joining. My name is Carl. So when I was a kid, one of my mom's favorite lines, or perhaps her least favorite lines, was, "Stop that before somebody gets hurt." Unfortunately, it didn't work very well. I was the second oldest of 4 boys in my family, and I was really reckless with my older brother above my head and snapped my collarbone. A year later, I dove headfirst into the corner of a brick fireplace, split open my head, led to quite a few stitches. And so that was just a sampling of my youth. In short, I was always testing the limits of the human body, specifically my own. And in college, I was lucky to discover biomedical engineering, which was a much safer academic way to test the limits of the human body, and also to invent technologies to overcome these limits. So to fast forward, I spent a short amount of time working with a medical device company. In graduate school, I studied the field of biomechanics. That's applying laws of physics to understand biological movement. Then my wife and I moved overseas to Italy for 2 years, and I worked at a rehab hospital there. So in 2014, I moved back to the States and joined the engineering faculty at Vanderbilt here in Nashville. And that's where I co-founded a research center that's focused on restoring health, mobility, and independence to folks with physical disabilities, or preventing injuries from happening in the first place through advances in science and technology. So that's about 90% of what we do. And then the other 10% is trying to turn ourselves into superheroes, meaning we work on human augmentation technologies to enhance our physical strength or endurance or reflexes or speed. So I'd like to just share a couple of short stories to give a window into the science and engineering of biomechanics, of prosthetics and exoskeletons, both now and into the future. So first, prosthetics. About a third of the research we do is focused on prosthetics, improving technology for folks with amputation. We work with veterans, we work with individuals who are in automobile or motorcycle accidents. And about 6 months ago, an individual came into our lab. He has below knee amputation. Let's call him John. He's a fit guy. He's a contractor, works on construction, flooring, woodworking. And the reason we brought him in was really to understand his activities of daily living and what he felt he was limited in because of his prosthetic technology. Now, John can walk, he can run, he can climb stairs. If he was wearing long pants and you passed him in the street, you may not even realize that he had a missing limb. But then we had him sit on the ground and we asked him to stand up. And I couldn't believe what he did. So he said, you know, my prosthesis just kind of gets in my way for this activity. And at that moment, he popped off his entire leg, used it like a crutch to climb up, and then popped it back onto his leg once he was standing. And my first reaction was I was blown away by his ingenuity. And my second reaction was, this is bullshit. No one should have to pull off their entire leg to stand up. If he's working on installing floors, if he's at home playing with his kids, he should be able to stand up without taking off his whole dang leg. So this is a great example of a seemingly simple task that many of us take for granted, but it's also a great opportunity for innovation. And this is the kind of project that my lab works on. This is why I get excited to go to work every day. We want to come up with creative solutions that improve lives, because for us, mobility is livelihood. So now we do work on a number of projects related to how to physically build better prostheses, but a lot of the grand challenges in prosthetics are centered around the problem of control. How do you coordinate these devices with the human body? Another project we have is for folks with above knee amputation. If you have one of these, you are 200 times more likely to fall over and get injured. And so we're working on building human-like reflexes that we build into robotic prosthetic knees to help reduce the fall rates in this population. Okay, tons of fascinating work going on in prosthetics, but I want to switch gears and talk about human exoskeletons. So the word exoskeleton conjures many images. People think of Iron Man's flying suit, or Sigourney Weaver's industrial machine at the end of Aliens, or the weaponized fighting machines in Edge of Tomorrow. Other people think of medical devices. So there are a number of FDA-approved exoskeletons that are for people who are paralyzed. They allow people to actually stand up and walk who are paralyzed. They're also being developed for people with stroke or cerebral palsy or a number of other disabilities. Now, exoskeletons are also becoming much more common in industry. Some of you actually may own a car that was assembled in part by exoskeleton-enhanced workers. And at their core, exoskeletons are wearable assistive devices that support or augment human movement. So my fascination comes from my personal life, started about 4 years ago when I started developing back pain. I attribute it to parenthood. I blame my kids for all the lifting and carrying and bending that goes into caring for young children. So I was curious, were there any exoskeletons out there for me as a parent? And unfortunately at the time I found none. I found the back belts that workers used to wear at hardware stores, but those have proven to be ineffective. And I found industrial exoskeletons, but they were too big and bulky and robotic and expensive. They wouldn't work for me, they wouldn't work for my budget, and my wife wouldn't let me spend $10,000 on an industrial exoskeleton. And so I was a bit salty, and it got me and my research team thinking about, can we design exoskeletons that are more like Tony Stark and less like Iron Man? So more like clothing and less like iron. Not just for me, but for millions of people in physically demanding jobs, like nurses or warehouse workers or construction workers. So over the last 4 years, we've been developing clothing-like exoskeletons called exosuits. They're textile-based, and what we do is we embed elastic elements into the suits that can be turned on and off just with the touch of a button. As a specific example, we developed a 3-pound suit that can take 50 pounds of strain off your back every time you lift or lean or bend forward. So we took this technology and spun it off into a company aptly called HeroWare to create a version for logistics and warehouse workers. And then in the research lab, we're now adding wearable sensors and machine learning into these suits to create truly smart assistive clothing. So what does the future hold for exoskeletons? In the next couple of years, the next decade in particular, these exoskeletons and exosuits are going to become commonplace in many industries and many aspects of life.
You have 1 minute.
These are technologies that are going to enrich our lives. They're going to complement what it is to be human. They're going to help us have more energy at the end of the day to do the things that we love to do. And they're going to help keep us safe, healthy, and physically active. So during this time of COVID in particular, we're surrounded by heroes in our community. And I'm excited about a future where each one of these heroes has their own exosuit, everyday super suits for everyday heroes. This is the future that is right around the corner.
Okay, Jerry, you've got 7 minutes. Make sure you're off mute, everybody. And here we go.
There we go. I found the off mute. Thank you. Now I have 7 minutes of rebuttal, right? To say why exoskeletons are not going to be useful at all. Is that what it is? Okay.
That's right.
Sorry. No, here, thank you. That was fantastic, Carl. So my first question is, can you develop anything that will enable me to do this? What Michael Jackson did in leading way forward. I actually mean the question kind of seriously, because what I'm asking is, how far beyond human capabilities will you be able to take us?
Yeah, there's so many opportunities, and really what you're going to see in exoskeletons over the next few years is devices being tailored for specific applications. It's funny you bring up Michael Jackson because that move he did there involved some patented technology that was made specifically for that purpose, so that they could do that particular motion. And so that's what you're seeing both in the medical side and on the industrial side of exoskeletons, people coming up with creative solutions that allow workers to more safely lift boxes or complete tasks with less strain on their body. Really, the possibilities are endless. I think with clever design, you can do all sorts of things by increasing people's endurance, increasing their strength, and increasing their safety.
Do you think there will become a time where prosthetics, or maybe you'll be implanting things, this will become elective surgery, not for people who have lost a limb?
I would hold off on the elective surgeries. So right now, exoskeletons and also prostheses are in general, they're very good at certain subsets of tasks. But what they haven't approached yet is the versatility of the biological limbs. The human body is so amazing in terms of the number of things you can do. We do it every day. You walk, you jump, you climb, and all the things that your body can do. Biology is still far superior for doing all sorts of tasks. But if you can identify specific instances where, say, you have somebody who is at high risk of injury, a nurse who's constantly helping with patient transfer or other activities, you can then potentially design creative solutions that help reduce the risk of that person in that situation.
Great. I have a question here from Hillary. Could exoskeletons help elderly so that we prevent falls?
I think there's definitely an opportunity to help elderly in a few different areas. Fall prevention is one of the active areas of research. There's a number of groups across the world looking at how you can develop technologies to help either prevent falls from happening or identifying when people are getting to the point where they may be at risk. And then can you train them to have better reflexes or stronger muscles so that they can support themselves? There's also the question of physical activity. How do you just keep people mobile and physically active, engaged in their communities for a longer period of time? I fully expect that when my kids are grown, my kids are 2 and 4 years old now, but when they're grown, I'm planning to have my hiking exoskeleton and go out on the trails and kick their butts. I think there's a huge amount of enthusiasm for using exoskeletons to help improve long-term health and physical activity.
Can I jump in with a question here? Sorry, Derek Muller. I just wanted to ask, as a father of 2 and a sore back, I wanted to know if you had tried using that 3-pound HeroWear with your kids and if that was effective. My other question is, if you wear this stuff, is there a risk that your own body gets weaker because you don't have to lift all the weight all the time. So how do you balance that?
Yeah, both great questions. For the suit that we have now, I think I'm most likely to use it for gardening and home improvement activities. Personally, I've stained my own deck a couple of times, and it is just really strenuous on the back. You're bent over for long periods of time. So that's an example where I in the future, basically refuse to do another deck staining at my house without an exosuit. To your second question, that's a great question. It's probably the most asked question we get is, hey, if we get these exoskeletons, this physical assistance, is this going to then cause our own muscles to weaken? And the short answer is it's highly unlikely from what I've seen that these types of augmentation devices would lead to long-term muscle atrophy. And I'll give you kind of two case examples. The first one is on the medical side. So exoskeletons are being used to help people who are paralyzed to walk. So if I got paralyzed right now, I'd have decades ahead of me where I'm basically wheelchair and bed bound. And so these offer the possibility of actually getting people up and moving and have the potential to actually build muscle mass. On the industrial side, you know, the jobs that people are in where they are looking at exploring or using exoskeletons are very physically demanding. If you go into a warehouse, some of these warehouse workers are lifting 35-pound boxes 150 to 300 times an hour for 8 to 10 hour shifts. And I did that every day, 5 days a week. And so the idea is if you were to reduce effectively what feels like 35 pounds down to 25 pounds or 20 pounds, it's still a really physically demanding job, but we can actually protect these individuals. And if you look at the science of muscle atrophy tends to occur when people are have dramatically reduced loads. So if you're launched up into space or you're bedridden or you reduce your physical activity by 90%. But that's not what these devices are being used for. They're reducing the loads by maybe 20 or 30% and help relieving strain off of folks that are at high injury risk.
I have a quick question. Hi, Christina Ochoa. Hi. Is there any consideration when it comes to patients that need these prosthetics with phantom limbs? Is there any kind of consideration when it comes to their psychology?
There is, prosthetics and also exoskeletons are so fascinating to me because of the interdisciplinary nature. So there are folks that are looking at the psychology of it. You're absolutely right. There are issues with phantom pain where people will feel like either their limb is still there or they're having pain in a limb that no longer exists. And so across the board, from surgeons who are coming up with innovative surgeries to help improve outcomes, to the prosthetists who are fitting the devices and prescribing the feet, to engineers and scientists who are trying to figure out, okay, 10 or 20 years from now, what could this technology be? How can it be more enabling to folks? There's the psychology of it. And that's part of what I love about this field is you interact with so many different people with different backgrounds. And it really does take everyone working together and approaching the problem with different perspectives to deliver a practical and effective solution.
I also have a question. If just to tap into what you're talking about with paralysis and beyond amputations and like maybe just like an accident happening, is there work also being done with people that are severely disabled in terms of enabling them to have mobility? And what is the level of interactivity like? What is the mechanism by which they control it? And are we moving towards seamless integration, or how far away is that?
Yeah, great question. So the back end of that, are we working towards seamless integration? I think that goes to the point of this control challenge. How do you design systems that can tap into the control mechanisms of the human body? Even if you're going for a walk, many people don't realize there's over 100 muscles from your waist down, and each of those muscles has about 500 motor units. These are nerves that go from the spinal cord to the muscles. And so your body is doing this amazing job of creating these coordinated actions. And how do you get that information to a prosthesis in a reliable way? There's a number of different approaches people are exploring. We're still a pretty good ways away from any solution that would rival biology, but there's been some really exciting progress in figuring out how to tap into either nerve signals or muscle signals and use those to drive prosthetic hands or prosthetic legs. And one of the questions you had in there was about other disabled populations, and there's a ton of research going on to try to develop technologies for people after stroke, children with cerebral palsy, multiple sclerosis. And so as the technology has matured, people have been looking for more and more applications, really in this very targeted fashion. You're not going to have the Iron Man suit that does everything. You're going to have a suit that helps a person with stroke do better, more effective rehabilitation. You're going to have a different device that helps someone with spinal cord injury stand up and walk, and a different device to help a worker in industry.
That's time. Thank you, everybody. We'll have the next speaker up in just a moment. Thanks, Carl.
Thank you all.
What are you doing? I know what you do. No payoff. There was no joke. We were just eating jelly.
Okay, Pat, you have 7 minutes.
Hello, everybody. I'm very excited to join you today to talk about the baby brain. I'm a neuroscientist very interested in how children learn, and a revolution is going on right now as we discover what makes the baby brain tick and what attracts that brain to allow the baby to learn. So brain science has improved across the entire lifespan, but the revolution that's occurring now allows us to look for the first time inside the baby brain while the baby's doing something, like solving a problem or looking at its mother or smelling something or trying to solve a problem. And so these technologies, which are perfectly safe and non-invasive, allow us to actually produce a movie as the baby's trying to solve a problem. So that's a functional magnetoencephalography record of the baby brain while the baby's doing something. We can also use structural MRI that allows us to watch the brain grow, kind of a snapshot of the brain at particular points in development, and relate that snapshot of brain growth, the areas and the connections in the brain, to that child's environment. So this brain science has added to what we've already known, which is that the brain is growing enormously in the first 5 years of life. At 1 year of age, the baby brain is 72% of its total size. At age 5, when we send our kids to school, it's 95% of the adult brain size. So all of this is going on in early development. It's absolutely critical. What are the game-changing findings? Well, there are two that I want to mention. And the first is how incredibly important the social brain is. What I'm saying is that the social brain is gating learning. You do not attract a baby brain unless it's in a social context. We've proven that by testing babies with brand new language exposure at, say, 11 months, which is a critical period in development for learning the sounds of a language, which leads to words and sentences. And so we've shown that if you expose a baby live to a brand new speaker at 9 months for 12 sessions of 20 minutes, that baby learns the sounds and words so well that they compete with the babies in the foreign country, say Taiwan or say Spain, that are learning that language exclusively. Their learning is masterful and incredible. But if you present that same material over a videotape and those babies look like they're learning, they crawl up to the set, it's a beautiful DVD, they touch it, they smile at it, you think they're learning, you do the brain test before and after, the live exposure to social interaction group learns masterfully, like magic. The kids who were exposed on a television set stare at it, learn absolutely nothing. So we're saying that in early childhood, the brain of the baby is controlled by social interest and social interaction. And we can actually see with videos that study what the baby's looking at during these sessions, eye movements, they track eye movements. They're socially adept at picking up the intentions and the sounds that go with words in a foreign language, and they pick up that knowledge incredibly. So, and the second thing is that we have learned how malleable baby skills are, whether it's language or whether it's math or whether it's other social or cognitive things. They're not fixed. This is not a fixed set of skills that children bring into the world. They need opportunities to learn. If you give them opportunities to learn, we can now track with MRI the growth of pathways in the language centers of the brain that grow as a function of the amount of talk they hear. So the more you talk to babies, and particularly the more you use this tone of voice called, and this register called parentese, this higher pitch, this slower talk, hello, how are you? That's how we talk to babies. They love it. It makes their brains grow. So we're able to link these measurements of the baby brain with that child's environment. And the outcome is that kids need opportunities to learn all over the planet, no matter where we study, and I've been in 8 countries. all babies have this potential to learn, but what they need from us is opportunities. It's opportunities to learn that unlevel the playing field. Without the opportunities, that brain doesn't grow. So what does this all mean for us? It means that these studies of baby brain development are teaching us how kids learn. It's going to be revolutionary for education. We can personalize learning, not only for typically developing children, but for children with disabilities of all kinds, autism, dyslexia, intellectual disabilities, and physical disabilities that make the world less approachable and understandable to a child who doesn't have access, say, to technology because of their difficulties. So the idea that we can revolutionize education and our understanding of children, that we understand about ourselves, that if the social brain is important, particularly during COVID, we're all seeing the real effects of not being in social communication with one another. I mean, there's just only so far you can go with even great video tools. The kids are feeling it too. The children, the teens, the primary school kids are really missing their friends. They learn tons from each other. They gravitate to one another. It's that kind of social brain that we're all walking around with all our lives that keep the brain in its most, in a sense, taxed, but most alive and awake and sort of interacting with others is the sort of juice for the human brain. And I think there's nothing like the present time to remind us just how important that social piece is for all of us, and particularly for the children. So I think that the future of this work is pretty exciting when you imagine what we might be able to produce. And so the idea that individuals are different, that each of these children, while they're all capable of learning, all of the children and all of us have very individual characteristics. And one of the things that neuroscience is going to be able to supply for education is a more personalized approach to what that particular child, and for us even as adults, what actually lights that brain up? What does it take? And how can we ensure that all of us, and particularly our children, reach their full potential? So, open to questions.
Okay, Kath, you've got 7 minutes. Don't forget to unmute.
Thank you. Hi, everyone. I'm Kathleen Felter. I'm a screenwriter based in Los Angeles, and I'll be emceeing your questions. And I'm joined by discussants Ahmed Best, who you met earlier, director and performer, Milena Govich, and Ashley Lorenz, chief of the Intelligent Systems Center at Johns Hopkins University Applied Physics Laboratory. So I'm going to start off with a question from the audience, which is, and I'll combine a little bit of my question in it as well, which is a question about when screens should be introduced. And my subsequent question into that is, you were talking about the difference between how babies interpret information when introduced through a person socially versus screens. And I was wondering if, because you also in your TED Talk, you mentioned this parentese that's universal. And is there something about the inherent cadence that we use with children when we're communicating with them, elongation of certain vowels and stuff? Is that part of it, or is it really about having to be in person?
Right. Okay. So first things first, the idea of exposing kids to screens, I say after the age of 2. I mean, there's evidence not from my own studies, but others, that the more screen time a child has, particularly if it's television, the more screen time, with each additional hour, there's 5 fewer words the child knows under the age of 17 months. So it's not just a neutral factor, it's a negative factor. Kids need social interaction, they need you, they need people, they need to manipulate the world, move with it, not just passively observe it. And so that's that one. And then the second one is, what was the second one? About?
The sort of parentese.
Okay. Parentese, I think, is this very natural tendency for us to take the listener into account. Parentese stretches the vowels, it slows speech down. Instead of the rapid pace I'm using, it is a slower paced speech that zooms up and down in pitch and attracts the baby's attention, gives the baby a time to coo back. And this back and forth dance is what communication is all about. The more conversational turn taking that kids are encouraged to do, the more their brains grow and their language outcomes are much better. So it's getting the brain used to this listen, serve, and return. back and forth. Parentese seems to elicit that from babies. It's like an elixir for the baby brain. You know, hello, how are you? It's slow. It has a positive valence. It sounds emotional. It's from the heart. You can't even teach people to do it. They do it naturally, but depressed people, parents, fathers, and mothers, if you're clinically depressed, you don't use that tone of voice. So we think it's very important. Our studies are showing that if you coach parents about the brain, social interaction, and tell them about parentese, and then just let them go, they'll use it more, they engage the kids more, kids start conversational and turning, and their brains go faster, and their language is better.
Hi there. I actually have a question. Milena here. I'm curious if in your studies, looking at language and this interaction, if you've studied babies' reactions to music or how music interplays with the young baby's brain and at what ages.
We have. So in similar experiments between 9 and 11 months, instead of exposing them to a foreign language, we expose them to music, the rhythm of a particular style, like the waltz with its bump, 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 bump. Turns out that babies who are in the experimental group and get that kind of listening experience and they tap out the rhythm of it, not only are better at detecting all rhythmic changes in music, they're better at detecting rhythmic changes in speech, like in a foreign language that they've not heard.
Wow.
And when we look at their brains before and after, we see that the auditory cortex lights up more in the experimental group compared to the controls who also played, but they didn't hear the music and tap. And their prefrontal cortex, which is a pattern detector. And so what things like music and dance and these kind of social, musical things that we've always done as humans together is to sort of tie us together and link us with patterns that we can do together. So it's social, but it also trains the brain to expect patterns in the world. And what we're all doing in this world is trying to detect the patterns so we know what's coming next. And so things like music, it reminds us not to take music out of the schools, not to think of art and science as separate, but they're unified. When you look at real brain, this stuff is all together. It's not as though music is here and language is there. It's not like that. It's that music and speech both require prefrontal cortex to detect the patterns. Once babies recognize, oh, there are patterns in the world, they focus on patterns, they look for patterns, and their whole world becomes more about detecting the patterns. It also reminds us that kids growing up in chaos, where the patterns aren't there, all there is in a chaotic world is nothing's going to be coming to me. I may not get fed. I will not be touched and loved. I might get beaten. You know, it's the uncertainty. It's non-predictable. It's not like the world of games and play in which the whole purpose is to interact with kids and show them the patterned world, which makes them feel safe and makes them trust. So these things, these experiments about things like music are teaching us things much beyond music. It's telling us how brains work and why early experience is so much a game setter for the whole of a child's life.
I'd love to jump in with a question. Loved your talk. My name is Ashley. So this is a bit of a self-serving question. I study artificial intelligence. We build robots. I'd love to ask you this big open question. How do we measure intelligence? It's hard for robots. My sense is it's hard for humans. You've talked a little bit about things like the size of the brain. We know that the connections among the neurons are important. You talked about language. In general, how do you approach this question of how to measure intelligence?
Well, 1 minute remaining.
And we know that intelligence is a multifaceted thing. Right? It's about processing speed. It's about the information you know. It's about the ability to solve new problems. So it isn't just one dimension. It's many, many dimensions. How you would measure that in an intelligent system, I think, is interesting. It's a challenge. But there are ways with little babies and children to detect what they can learn from exposure to something. How does their eye gaze patterns follow the new information? I think this world between human learning and machine learning and their interaction, and whether or not, I think it's an open question whether children can learn from a social robot. If we need social interaction, and particularly during COVID, we sort of wonder, how can we make machines more social? And is that a good thing? Should we, I'm not trying to say we should supplant for infants a social robot with a person, but it is an intellectual question that needs solving. What does the brain interpret as social? What's a social agent to a baby?
Thanks,
I
Pat.
have a question really quick.
Okay, go for it, Om.
Congrats. All right, my question really quickly. What can we do during this time where we're all isolated and our children want to see their friends? What can we do to help them in this time and give them the socialization and comfort that they need that they're not getting from their friends?
Right. Well, the little babies are probably quite happy because their parents are home. So I think I worry less about the little ones, but I think the 3-year-olds want to see their friends. And starting from 3, I think they can understand that the screen can represent a sentient human being, particularly one they know, grandparents, you know, and other friends. So I think I would encourage them with parents to interact, to show that's Johnny, you know, that's Sarah, and sort of hold up frequently played with toys, try to do interactive things so that they get some sense that the world hasn't changed, that their friends still exist, and that social world will come back in person. And in the meanwhile, we're doing the best we can to allow us to see one another and interact. That's what I would do.
Thanks, everybody. We'll have our next speaker up in just a moment. Thanks, Pat. Thanks, Kate.
Thanks, everybody. Bye.
Okay, Moon, you've got 7 minutes.
All right. Hi, everybody. My name is Moon Duchin, and I have 7 minutes to tell you all about gerrymandering. So let me try to do that. I'll start by introducing myself. So I'm a mathematician, and I'm the super duper theoretical kind of mathematician. So what I studied in my dissertation was like the 18-dimensional space of 4-hole donuts and what happens when you twist them randomly for a really long time. In other words, nothing to do with anything in the world. And these days, I take that super pure abstract math and I apply it to politics. So back in 2016, around the time of the presidential primary, I was teaching a class on voting, and I got really interested in what cutting edge math might have to say about redistricting. And like, can we really figure out what is a gerrymander and what is not? So I took all of that science of the random donut twisting, and I said, what if instead we used it to make random districting plans? So I'm going to tell you a little bit about that. I'm going to tell you how we can take random partitions, like take a state and cut it into chunks in lots and lots of random ways. How is that going to give us some insight into whether, you know, North Carolina or Pennsylvania or my home state of Massachusetts is gerrymandered? And that could be gerrymandered for a political party, racially gerrymandered, you know, whatever it is. We'd like to understand a districting plan from the point of view of math. Okay, so here's the main idea that I want to get across. It's that all the signs and signals that we think we know as signs of gerrymandering are actually really muddled by some very difficult math under the surface. So I would say to you probably there are 2 ways that you think you can spot a gerrymander. One is really strange shapes. If a district looks more like a praying mantis than it looks like a plump blob, you probably think somebody's trying to do something. And the other way that people think they know a gerrymander is just by comparing votes to seats. So if the 2 parties have half of the votes each, suppose you're in Pennsylvania or North Carolina, and it's just about 50-50 voting, but yet the congressional delegation is really tilted to one party or the other, and it happens to be the party that drew the map, then you think you know a gerrymander. So what I started to discover when I got into the science of gerrymandering is that the shapes actually do a lot less work than you think, for one. And secondly, those disproportions, those numbers, could just be a consequence of where people live sometimes, and not a consequence of like mustache twirling gerrymanders. Okay, so let me give you a simple example to illustrate the idea that those signals can mislead you. So here's one. In North Carolina, a bunch of good government groups looked at the North Carolina plan, and they said, you know, this is a gerrymander, and here's one way we know it. We have all these examples of neighbors who live right across the street from each other, but the district line cuts them right down the middle and puts them in different districts. That's got to be a gerrymander. But actually, if you look under the hood, what's going on when you make districts is that you have to use units from the Census Bureau called census blocks, and those units cut along streets. So the fact that you're cleaving neighbors from their neighbors across the street that's just a function of how districting plans are made, and it doesn't have anything to do with anybody twirling a mustache anymore. And that's what I try to do in my work on gerrymandering, is I try to tease apart the effects of the rules and the effects of where people live from the most extreme advantage that a party could possibly get by controlling the process. Okay, so how do you do that? That's the task. Well, how do you make it happen? So here's what we do. And this has been a dream since the 1960s, but this dream has finally been realized just in the last few years. So the idea is this: get a computer to draw not just 5 plans, not just 20 plans, not just 1,000 plans, but what I would technically call millions of plans. That's what you want to do. You want to build an enormous variety of different districting plans according to the rules. So if I tell you what the rules are in North Carolina, I tell you what the rules are here in Massachusetts, and I get a computer to sample from that universe of plans just according to the rules. If I make a big enough sample, it will eventually become a representative sample of all the possibilities. And so it'll give me some kind of bell curve, typically, of what the different things are that you could measure. So you could look at, like, what do the shapes look like? How eccentric are the shapes? You could look at how many seats do Democrats get, and you'll get a bell curve. And then if the actual plan that the politicians propose is all the way out in the skinny part of that curve, that's a pretty good red flag for you. It's a flag that something was happening not just according to the rules. But one of the really important things about this method is that it's never going to read people's minds and tell you what their agenda was. So this method is just going to tell you that something smells a little funny. It looks different from what you'd expect, constructed by the rules. Okay, so that's the goal. And the method that I'm talking about is called the Ensemble Method, because that giant collection of plans that you build, that's called an ensemble of plans. So the whole point here is, if you want to evaluate a plan, build a big ensemble of other plans that are built by the same validity checks and all the same rules, and compare your plan to those. Okay, and this logic has wormed its way into litigation over gerrymandering in the last few years, and courts keep finding it persuasive. And then for those of you who follow the litigation, what happened last summer was that the Supreme Court finally heard all these big cases on gerrymandering all at once. They heard all this evidence. They heard about all these computer methods. They read about them in a brief that my group wrote, a mathematician's brief for the Supreme Court.
1 minute.
And then they thought about it all, and they said, you know what? All 9 justices essentially stipulated, like, this seems relevant. Yeah, we believe you. You can understand that world of possibilities. Sadly, what happened next is maybe a little bit predictable. The court then cleaved along ideological lines, with the so-called conservative justices on one side and the so-called liberal justices on the other. And the conservatives, who had a 5-4 majority, said, yep, you've done it. You've done this thing we've asked for a really long time. You've built this bell curve. But even if you're way out in the tails, how far is too far? That sounds really hard, so the Supreme Court's not going to think about this ever again. And that's where we are. So federally speaking, these methods are out, but they're very much alive at the state level. And one of the happy pieces of news that I have to report is that I hear from new legislatures and map makers every day looking for help trying to understand how to make better plans. So I come from a background of 18-dimensional donut space into a place where I get to help people make plans that live up to their rules. That's what I'm talking about.
Thank you, Moon. Diana, you have 7 minutes. Please don't forget to unmute.
So this has been amazing. Thank you so much. So I want to start just a really super broad question. As you're looking at all the data, what states right now, where you think like the playing field is most level? And then what state do you think is wildly imbalanced? And in both of those, like what are your like key indicators?
Yeah, totally great. So we've looked at a whole lot of states and we've tried to understand, I started out by saying you can't always tell a gerrymander just by the signs, by the signals that are the most obvious, because sometimes it just has to do with like how the chips fall. And what we've seen is that that's a lot more true in some states than others. So in 2018, I was actually consulting for the Pennsylvania redistricting process. The governor hired me as a consultant to help them think about what a fair map would be after the state Supreme Court invalidated the last map. So this was perfect for me. I got to come along and like do my data science thing and try to look at how the maps were tilted. And what I found is that Pennsylvania, just as a consequence of where people live, has a huge tilt in favor of Republicans. So even though you see a just about 50-50 split in voting in Pennsylvania for instance, in the 2016 elections, if you actually look at how the plans fall, even though there's 18 seats, it's very rare to see a 9-9 split. Something about that playing field is tilted several seats in favor of Republicans. But here's what my analysis found. Even though Republicans have a natural advantage of several seats, the Republican legislature took that advantage and squeezed it as hard as possible to create several more seats of advantage for Republicans. And the state Supreme Court agreed, and it threw out not only the original Republican legislature plan from 2011, but also the do-over from 2018. And then by contrast, another purple state that looks pretty level is Virginia. And these are the kind of things you can't just guess by looking at a map. But when we do our like in-depth analysis of Virginia, we find that they have about 50-50 voting patterns. And if you just randomize plans, what you'll find is that the peak of that bell curve is at about a 50-50 outcome. And I don't, what I'd love to understand, what's a long-term project, is to understand why. What makes Pennsylvania so advantageous to one side while Virginia stays a pretty level playing field? For now, our methods, which are pretty good, and we're pretty proud of the breakthroughs in the last few years, they can show us the lay of the land, but they can't yet answer those why questions.
Jerry, did you have a question?
I have a question for you.
Oh, sorry. Just answered it. What? I was just going to ask if you have any clue as to why, when it's naturally imbalanced, you said naturally, why that is, what causes that, but it seems that you just said you don't know that answer.
Well, it comes down to what you might call the human geography or the political geography. It comes down to where people live and how they vote. And I would say one thing that when I started getting really excited about the science of gerrymandering, I sort of took in the conventional wisdom that said Democrats are going to be at a disadvantage everywhere in contemporary America because they're really packed into cities. Or as fancy lawyer Pam Carlin puts it, Democrats like to huddle for warmth in cities. And so if you have Democrats packed into cities, then you might also see them packed into districts, and they'll waste a lot of votes in certain districts and then pay the price in other districts if they lose narrowly. And actually, what I'll say is that after several years of studying this problem really hard, I'm going to do the typical scientist move. It turns out to be more complicated than that. So there are very intricate effects of the geography that control this tilt of the playing field. And ask me again in 3 years and I might have a punchier answer. But for now, I can say it's not just about density. It's something much more intricate about the geometry of where people live.
Thank you.
I'm curious, I have a sort of a process question. It feels to me like there's an increasing focus on specialization in science. And the nature of your work seems incredibly interdisciplinary. And I was wondering if you had a moment where you kind of were inspired to see across disciplines, or if there was anything particularly surprising that you found correlated or connected between different fields.
Yeah, thanks. No, you're right. My work is aggressively interdisciplinary. And actually, I run a lab that hires people with a background in policy, geography, computer science, math. We had a philosopher who just moved on a little while ago. So we're super interdisciplinary. And one thing I would say, I completely agree with you. Like, universities aren't set up very well for this kind of interdisciplinarity across like math and the social sciences and so on. So like for me, the magic word was tenure. I got to a point where it's hard to fire me, and then I said, hey, now I can work on civil rights.
I'm curious if you can use or have thought about using mathematics to explore the effectiveness of the Electoral College, like to expand it, like to see how that might work in terms of the same dynamic.
Yeah. So the Electoral College has a lot of the same dynamic. Yeah, I agree. Because the way the Electoral College works in all states but 2, so the only exceptions are Maine and Nebraska, which they can split their electoral votes. All the other states, it's winner take all. And winner take all introduces some real non-linearity into voting. And exactly, you're right, in exactly the same way that districts do.
1
So
minute.
that you can try to model the effects of the Electoral College. But I will mention one thing. Over the last few years, I've gotten interested not only in redistricting, but also in voting technology and security and voting auditability. And one thing I'll say about the Electoral College, it sounds totally outdated and old-fashioned and kind of obnoxious if you don't like the results, right? But it has one merit that I hadn't appreciated until just a couple years ago, which is the elections are now binned in a way that makes them easier to audit. So if you worry that your election's been hacked, you can now audit it state by state. Whereas if we had a national popular vote, I know this is kind of a like minutia from the point of view of like the big picture of fairness, but if you think about what it would take to audit an election where a vote in Idaho counted in exactly the same way as a vote in Missouri, for me as someone who really like thinks and worries about election security, that sounds like a small nightmare. So the days that you wake up and you're railing against the Electoral College and how unfair it is, at least comfort yourself with the thought that it makes it easier to make sure that your election was carried out correctly.
Okay, thanks, Moon. Thanks, Diana. Thanks, everyone. We'll have our next speaker up in just a moment.
All right. I don't know if anybody can see me, but if you can't, at least you were spared the aesthetic offense of having to look at me. Let me just say a few things that are mostly relevant to people who make films or TV shows about aliens. And that is the following. The questions that I get from screenwriters, producers, directors are almost always the same three questions. Why have the aliens come to Earth? What weapons do they have? And what do they look like? Okay, now, if I had the answers to all these things, I wouldn't be speaking to you now. I'd be on a plane to Stockholm to collect a big prize. Because the bottom line is, we have yet to find any aliens. In fact, we haven't even found alien microbes, you know, and there are at least 7 other places in our solar system where you might find microbes. I mean, under the sands of Mars, some of the icy moons of Jupiter and Saturn, those are all places where there may be life. And I think you're the first generation that's actually going to know that there is other biology out there. But when it comes to aliens, people are interested in aliens, I think, primarily because they replaced those old Soviet bad guys in the movies, right? It's a little tough to come up with with bad guys now because, you know, it's just not quite as politically correct as it was. Whereas aliens, you can make them as bad as you want, and they have unlimited powers, and they can do anything you want them to do, and they don't ask for residuals. So there is this interest in aliens. Now, why do we think there are even aliens out there? Is that just a figment of our collective imagination? No, we now know something that we didn't know even 2.5 decades ago, and that is that there are planets everywhere. Planets are as common as, you know, phone poles, right? Okay, and the fact that there's so many planets, we also know, implies that there are a lot of planets that might be a good Earth 2.0. You know, we found at least a couple of candidates. It's hard to actually know whether this planet has oceans and continents and continental drift and all the things that you think you might need for your gusto-grabbing lifestyle. But nonetheless, there are estimated 50 billion other Earth-size worlds just in our galaxy. 50 billion, that's a big number, right? If you won that in the lottery, you know, you change your lifestyle. 50 billion, that's our galaxy, and there are at least 2 trillion other galaxies we can see, each with 50 billion. So it obviously seems to make sense to assume we're not the only kids on the block, and there are a lot of other kids. Keep in mind that 1/3 of the public thinks that the aliens are not only out there, but they're here, right? Teasing the Navy in these videos or hauling people out of their bedrooms for these unauthorized experiments. Okay, that would be great. If the aliens were here, that would be terrific, but it would also mean that the next time you go to an airport, I think I can remember what an airport looks like. The next time you go to an airport, you know, they might say, oh, well, there's some unidentified craft in the area, and we're shutting it all down for the next 2 days. I don't think that happens to you very often. I don't think we're actually being visited. But let me just address briefly what the aliens might have in mind and what they might look like. Now, to ask what sort of weapons they might have, that's of production interest, if you will, for the films and TV people. I mean, we don't know what they do. weapons they might have. I mean, it's like asking Neanderthals, what sort of weapons do you think the military will have in the 21st century? I mean, they say, well, they're really good sticks or whatever they'd say, but it'd all be wrong. Okay, so you can just make the weapons whatever you want to make them. I don't think they would involve throwing heavy metals at one another with gunpowder. That's a pretty old technology, and it means that most of the time you miss. If you can shoot photons, if you can shoot light, X-rays, something, then you never miss. And, it's kind of boring, but you never miss. The second thing is, what do they look like? Who knows what they look like? But in the movies, they tend to be these little gray guys with big eyeballs and no hair, and no pets, no clothes, no sense of humor. It sounds like my relatives, right? But we don't know whether the aliens look like that or not. But it saves you a backstory because now everybody in the theater knows, oh, Bob, those are aliens. You don't have to, don't need to explain, right? If the aliens look like, I don't know, some sort of printing press or my bicycle or something, you wouldn't know what they are. This way you know what they are. There's no reason to think the actual aliens would look that way. Let me just finish off on why they would come here. Because I think in 8 out of 10 sci-fi films, when the aliens come here, it's bad news. They're out to do something terrible, like, I don't know, blow up the earth or something like that, which, by the way, is a very expensive thing to do. You can work out the amount of energy it takes to blow up the earth. And honestly, you could do a lot more in terms of, building theme parks or whatever on your own planet instead of going and blowing up somebody else's planet. All right. Now, they might come for, well, some natural resource. In most sci-fi films, they come for the water. The water. If they want, water's all over the universe, right? 3/4 of the universe by weight is hydrogen, and most of the rest is either helium or oxygen. If you have oxygen and hydrogen, you can make H2O. It's everywhere. If you really want the water, why not go to one of the moons of Jupiter, which have a lot more water than the Earth does, and take it, and nobody will try and defend it. You won't run into people saying, wait a minute, that's our water. Okay, so that doesn't make any sense. Is there anything else here they might want? Now, I've been on panels to discuss this, and people say, well, maybe they're coming for the molybdenum, or maybe they're coming for the rock and roll, or maybe they're coming for, they want to breed with us. That doesn't make any sense. I mean, you're not breeding with other species. At least I hope you're not, right? I mean, you don't go out in the backyard and grab a squirrel. I'm abducting you for breeding experiments. Not going to be comfortable for either you or the squirrel. And beyond that, at least the squirrel has DNA and the aliens won't. So there's absolutely no hope for that. Nothing makes sense. The only reason they would come here is because they are scientists and they're kind of interested in cataloging the intelligence in the universe, or they're just interested in our culture. Okay, we're going to take the best of your culture and, stack it up in a library somewhere on our Klingon home planet. But beyond that, it's a big trip. It takes a lot of energy to do it. They better have a better reason than I've given you. Come in, Earth.
All right, so Seth, are you ready for Christina to jump in?
I'm ready for anyone to jump in. I mean,
you have like 20 seconds. There you go. Christina, you've got 7 minutes.
Yes. Hi, Seth. I have been looking at the questions, and a lot of them are about the odds and the statistical probability of us finding, at least in our lifetime, since the 60s, since Drake came up with his equation. How has that changed, with the subsequent discoveries that we've made and kind of like recent space exploration?
Yeah, well, it sounds like the audience is very well informed if they're asking about the Drake equation. By the way, I might point out that Frank Drake will enjoy his 90th birthday in 72 hours from now. So there you go. Send him a card. But the equation doesn't give you an answer. The equation is designed to kind of estimate how many aliens are out there, doing their thing as we sit on Zoom here and do our thing. And the answer to that question is, we don't know the answer to that question. Obviously, we don't. But if you say that 1 in a million stars has aliens, right? I mean, there are a couple of 100 billion star systems in our galaxy. So 1 in a million mean there are hundreds of thousands of societies. Some of them may have already blown themselves up, others may not. But it's impossible to know how many are out there until you see them and count them. It's like saying to, the explorers of the 1500s, okay, you guys are going to be the first to go to South America. How many undiscovered species do you think there are there? No idea. You have to do it. You have to do the experiment.
Yeah. So also we've been, we also just heard Moon talk about this, and I think it's in everyone's mind when it comes to the political climate and you know, the public's perception to science, and everyone talks about knowledge being power and how we can change people's minds. When was the last time you encountered data, information, or an argument that fundamentally changed your mind about something?
Well, I'm tempted to say never, but that's not quite true. Besides, that would say more about me than the questions. But it is true that people do have fixed ideas about almost all of this. I hear from them every day, mostly from people who've seen something in the sky they didn't understand, right? They're going down the 405 freeway and then they see something and they think, you know, Bob, that's an alien craft. Well, maybe it is, or maybe it's an airplane going into Los Angeles airport. I mean, you know, that would be a great change in my perception if you could prove that we're being visited. As I say, 1/3 of the public is convinced of that. That would change things. But the other thing I think is that we're very, very parochial in our view of aliens. They always are kind of like us, and they're always interested in our lives, right? They've come here to keep us from destroying ourselves with climate change or something like that. I mean, you don't do that. I don't go in the backyard and stop the ants from, you know, engaging in war all the time. They're always warring with other ants. You guys got to stop this. This is morally wrong. Well, they're not going to listen to me, and if they do, they won't understand. So I think you have to look at it that way. And the other thing that Hollywood always gets wrong, not deliberately, but it's a matter of making a good story, is that the aliens are always biological. We like biology after 8th grade anyhow. Everybody likes biology. But the aliens will have invented artificial intelligence. We're doing that in this century. And artificial intelligence has no limits on what it can do eventually.
I know we're also joined by our panelists, our discussants, Kath, which you met a little bit earlier, Mike Ireland, and Phil Plait. I think they have a few questions for you as well.
Okay, well, just don't let Phil Plait ask any questions.
Phil, you've been warned.
I will stop, Phil. I will ask you just quickly. Always love watching you speak, Seth. In 2012, in your TED Talk, you kind of famously predicted that by 2036, we'll have had concrete proof of alien intelligence, and you bet the audience at your TED Talk a cup of coffee if you were wrong. Do you feel like we're still on track for that, or should we be buying these Starbucks gift cards?
Yeah, well, you don't have to buy the Starbucks gift cards. I do. Now, if I'm wrong, but I will stand by that, Mike, because simply on the basis of, yes, the astronomy has changed a little bit. We now know that maybe 1 in 5 star systems has a planet about the same size as the Earth and about the same average temperature. That sounds good. But the other thing that's changed enormously and is always changing is the speed of the search, the technology used to check any place for signals. The other thing to keep in mind, I mean, we've been looking for signals since, 1960, but, you know, the aliens, there may be aliens out there that are billions of years more advanced than we are. The idea that they would sit in a cantina with a bunch of other aliens and order a drink, I mean, that's a nice thought, but that's very unlikely. So the question is, are we being very careful in our astronomy to always check out anything that looks unusual? Because, you know, somebody who's a billion years more advanced than you are might be doing things you really haven't thought of.
Okay, I'm going to jump in unless...
They've lost all interest.
We've lost them all. Not mine. I have 30 more. How many more minutes do we have? What is the most accurate representation of experts in your field that you have seen in the media? Not the aliens themselves, but of scientists and astronomers.
Well, of course, we have no idea what's accurate or not, because in order to know what's accurate, you need to know what the real answer is. You have to have the back of the book and look up what the real aliens look like and then say, oh, well, that movie didn't get it right. I don't have any problem with the way the movies depict the aliens, but I do like when they, you know, do a different idea that the aliens just didn't come here for the usual, you know, malevolent reasons. I don't know if many people saw Arrival, where they land on these sort of black bananas and they sit around trying to teach language to somebody. I mean, that's at least different. And one thing that I noticed was that these aliens, you never see them entirely, but they kind of look like sea creatures. And I figured that the Japanese will, in fact, start farming these aliens, because I reckon you could get 2,000 orders of sushi out of each alien. So at least you can make some use of the aliens.
What are your thoughts on the public deciding to storm Area 51 and things like that happening in the general population?
Yeah, well, if you want to go storm Area 51, you could do it, but Area 51's out in the desert, the Southern Nevada desert. There's no good restaurants there. There are no restaurants, good or otherwise. There's really no place to stay except maybe the little Ailey Inn. Most of the people who were trying to storm Area 51 were the media watching other people storm Area 51. So that storm kind of petered out. There are secret things going on at Area 51. I have a friend in a book club who actually worked there. And, it's military aircraft. That's what's there. The idea that the aliens are always in the American Southwest for some reason. You don't see them in Indiana much or, some of the better places to live. They always come to the American Southwest. And I figure it's because the aliens have a penchant for Tex-Mex cuisine.
Unfortunately, that's all the time we have. Thanks, Seth. Thanks to all our speakers. Thanks to everybody who joined one of these conversation circles. And of course, our MCs. Thank you, Christina, and everybody else who led a conversation. And I think this is our time to get back on and wrap it up to a fast depleting audience.
Well, we still have most of our audience, and we want to thank all of you for being here. This was our grand experiment to figure out how we could migrate speed dating from the real world to the virtual world. And we hope you agree that if nothing else, what we did manage to deliver were 5 amazing speakers to talk about incredible science, and that we also managed to have an amazing group of discussants and MCs. And I think, as I said at the top, this is always great for us because we get to learn something new. And we will get to learn, it is actually, Seth is sort of a great segue to our tease for next week's event. We've been doing our events on Wednesday afternoons. Next week, we're going to do Thursday afternoon. That's right, you've got the prop because Kevin Hand will be with us and he will be talking about the search for alien life. Maybe not about those kinds of aliens that Seth was specifically talking about, but the kind of life that we might find on other planets and that they do follow the water. So Kevin will talk about the research that he does here on our planet to extrapolate from that to tell us what we might learn about looking for aliens elsewhere in our solar system. So please come back next week. We'll send out an invitation. And I think you probably want to tell everyone that we're going to send out a survey.
Yeah. Well, there are 2 things. One, I want you to know I took my timing very seriously. I had a backup, an analog backup, just in case. But also, I want to thank everybody for coming. And please, please, please take our survey this time around because we will be sending you a survey if you RSVP to this event. And we have all kinds of questions about whether or not this format's working. We loved it, but we want to know whether you loved it.
And we want to know whether you like the music. So let us know that too.
The music was awesome. Come on now.
So until next week, thank you again for being here. We will be back next week. We hope you will be also. And if this was your first time to an exchange event, we hope we got you hooked with this and that you will return for another go round. So thank you. Bye.
Thanks a lot, everybody.